All right, we're looking at P8. Our goal here is to solve quadratic equations using the square root method. And before we do too much, I want to look at a quick investigation. Right? If I said that 7 squared, we know 7 squared, the meaning of that is 7 times 7. And we know 7 times 7 equals 49. Right? And I also want to take a look at what happens at negative 7 squared. Well, negative 7 squared is negative 7 times negative 7. A negative times a negative is positive, and 7 times 7 gives us 49. So as we solve, when we take a square root, we get both the positive and negative answer. And what I mean by that is, if we're looking at the square root, so if we had an example where we had x squared equals 49, well, something times itself twice is going to be 49. Well, we already know what that answer is going to be. So we'd square root both sides, and we get x equals the plus and minus 7, both the plus and the negative version of 7. So, when it comes to solving quadratic equations using the square root method, what we want to do is we want to isolate, so our first goal is to isolate x squared. I need to get him by himself first. Sometimes that's already going to be done for us, and sometimes we're going to have to do a little bit of work to get that. You'll see what I mean here in a little bit. Then once we get to that point, we're going to take the square root of both sides, and that really is as far as we're going to take it. So, let's take a look at a few examples and see exactly how we're going to get this done. As we've already seen, x squared equals 49. We're going to take the square root of both sides. We got x equals plus and minus 7. Let's take a look at one that's not so obvious, right? Here we go. X squared minus 5 equals negative 4. All right, so here's my x squared, and it's x squared minus 5 equals negative 4. Well, I want to get x squared by itself first. So in order to do that, I have to add 5 to both sides. So I add 5, and I get x squared equals, well, negative 4 plus 5 is 1. Now I square root both sides, and I get x equals plus or minus 1. And I'm done. That's as far as I need to take it. Let's take a look at another example. We have 7x squared equals 21. Well, now I have a multiplier in front of x squared. I have some number in front of x squared, and we know that between 7 and x squared it's multiplication, so we get rid of that with division. So we're going to divide by 7, and we're left with x squared equals 21 divided by 7 is 3. And now when I take the square root of both sides, I end up with x equals plus and minus. Well, what's the square root of 3? Well, it's not quite obvious, right? It's 1 point something or other. So here, we're just going to leave it as the square root of 3. And that's it. Now x equals plus or minus the square root of 3. No sense in taking it too much further than that. Alright, now we got one. It's going to be a little bit more involved here. So 10x squared plus 2 equals 292. That seems like a lot, right? So again, my idea here is that I want to get x squared by himself first. So I subtract 2 from both sides. I'm left with 10x squared equals, well, 292 minus 2 is 290. Divide by 10. And now x squared equals 29. Take the square root of both sides. Since x squared was by itself, then I take the square root of both sides, and I get x equals plus or minus the square root of 29. And I'm done. That's as far as I need to take it. So one thing I want to take a look at, so note, let's take a note here. All quadratic equations can be represented in the form of ax squared plus bx plus c equals 0. And when it comes to the square root method, so the square root method, this middle term is missing. Alright, it's really important to note that. If you're ever solving a quadratic equation and there's no middle term, there's a really easy solution.